Good afternoon, good morning, students. In the last class, we discussed about the lyophilic salts and also means lyophilic colloids and lyophobic colloids. Okay. In today's class, we are going to discuss with the difference between lyophilic and lyophobic colloids. Understand? So in that, the first one is lyophilic, second one is lyophobic. Okay? So students, first one is affinity. They have affinity towards what? Dispersal medium. Towards medium. Next. Of course, they don't have affinity towards medium. So all the differences are very important for 2 marks in all chapters. Each and every difference. Next. These are reversible and these are irreversible. This can be reversible and that cannot be reversible. Next. Viscosity is more than that of viscosity of the colloids is more than that of medium. Similarly, surface chemistry and surface tension is more than that of medium. Viscosity is same as medium. Next, surface tension also same as medium. Here, both are greater than medium, that is solvent, that is exactly equal to medium. Next, so these are cannot detect easily under ultra microscope. Under ultra microscope. Okay, these cannot detect easily under ultra microscope, and of course, this is detected easily under ultra microscope. These are the difference between the lyophobic and lyophilic colloids. Understand? So if you apply any electrical current for this, then students here they easily migrate to migration is easy. Migration is easy. Migration is not easy. Is not easy. Migration means movement. Okay, that is easier, that is tough. Okay, so this is all about the difference between the lyophilic and lyophobic lyophilic and lyophobic colloids. They may also ask lyophilic salt and lyophobic salt. Colloids nothing but salts only. Understand? Liquid medium means liquid dispersive medium and liquid dispersive phase. Okay, so this is all about the differences. So students, next we are going to discuss other type of classification of colloids. This is what first one we discovered based on physical state like gel, solid, solid salt, foam, and solid aerolizer and gas liquid aerolizer. Correct? And also this is the second classification based on attraction between the dispersive phase and the dispersive medium. Okay, so third one classification is based on aggregation of molecules. Third classification is based on aggregation of molecules. Okay, so aggregation means collection together. Understand? Aggregation means collect together, you think. Collect together. Okay, so in this three types is there. One is multimolecular. Second one is macromolecular. Third one is associated. This associated nothing but associated colloids, nothing but miscellaneous. Remember that. One is multimolecular colloid, macromolecular colloid, associated colloid. Based on what? Aggregation, collection of the colloidal particles. Understand? So what is this multimolecular? So students here, what is this aggregation means? If in a solution you take, so what is the range of the size of the colloidal particle means in between 1 nanometer to 1000 nanometer. Okay, aggregation means collection I told. So upon dissolution means if it is a solvent, when solute is dissolved in this solvent, it split into ions. Ions are any molecules. It may be simple atoms or ions, anything. So then the size of those ions upon dissolution become very small. Understood? Are you getting? If any solvent is there, upon dissolution means solute is dissolved in solvent. ಇದರಲ್ಲಿ solute ಅನ್ನು dissolve ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Dissociation ಆಗುತ್ತೆ, dissolution ಆಗುತ್ತೆ. Dissolution ಆದಾಗ particles split ಆಗುತ್ತೆ, small ions ಇಂದ small atoms ಆಗಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ? The size of that is less than 1 nanometer. They form a true solution or crystalline. Understand? So we want colloidal solution in between the size range 1 nanometer to 1000 nanometer. ಅವಾಗ ಏನಾಗುತ್ತೆ? ಈ ತರ ಸ್ಪ್ಲಿಟ್ ಆಗೋ ಅಯಾನ್ಸ್ ಇರುತ್ತಲ್ವಾ? ಓಕೆ. ಸೊ ಸ್ಪ್ಲಿಟ್ ಆಗಿರೋ ಅಯಾನ್ಸ್ ಈ ತರ ಚಿಕ್ಕದಾಗಿ ಸ್ಪ್ಲಿಟ್ ಆಗಿರುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Okay, they collected together, associated together, aggregate together to form a molecule or any colloidal particle of size in between 1 nanometer to 1000 nanometer. They collect with each other, layer by layer by layer, multi-molecular, so many molecules collected together to form a size in between 1 nanometer to 1000 nanometer. That is called as multimolecular colloid. Means upon dissolution, what it is? Okay, let's say. Okay. Upon dissolution, a large number of atoms or molecules collected together to form a size range between 1 nanometer to 1000 nanometer. Then only they called as colloids. So this type of colloids is called as multimolecular. Then this is macromolecular. What is macromolecular means? It is also called as polymer colloid. Polymer colloid. So you know, starch is there, cellulose is there, Understand? Those are very big molecules, macromolecules. Then those macromolecules, when they dissolve in solvent, is dispersion medium. Macromolecules like starch, protein, cellulose. Of course, these are very macromolecules. Their size is more than 1000 nanometer. Then what happens? When they dissolve air, understand? When they dissolve air, they form smaller units. You know, when starch is decomposes, forms n number of glucose monosaccharides. Cellulose also forms n number of saccharides, monosaccharides. They splits into smaller ions. Means macromolecules, when they dissolved in a solvent, a suitable solvent, they what? Okay, they split into a smaller ions. So those smaller ions again associated with each other like this. They come each other to form a size in between 1 nanometer to 1000 nanometer. So that type of colloid is called as macromolecular colloid. Understand? So this is called as macromolecular. Means the colloidal particles is done by the dissolution of macromolecules in the solvent. That is macromolecular colloid. Another one is associated. So students, what is associated means? Listen, for example, any ions, for example, NaCl unit, it is not NaCl, just I am telling you. If any salt is dissolved in a solvent USO, they form ions. Understand? Any salt, for example, NaCl, if NaCl dissolved in water, it forms Na plus and Cl minus. So at low concentration, it becomes low concentration, it becomes an electrolyte. At high concentration, it becomes colloid. How? Just an element in control. 1 cup of water na the transparent glass ಅಲ್ಲಿ ತಗೊಂಡು ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಸಾಲ್ಟ್ ಅನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ಅದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಇರುತ್ತೆ. ಇನ್ನು ಸ್ವಲ್ಪ ಸಾಲ್ಟ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಇರುತ್ತೆ. ಇಫ್ ಮೋರ್ ದ್ಯಾನ್ ದಟ್ ನಾವು ಆಡ್ ಮಾಡ್ತಾನೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ? ಅದು ಸ್ವಲ್ಪ ಟರ್ಬಿಡ್ ಆಗುತ್ತೆ. Turbid means the transparent solution somewhat changes to white in color. Turbid, that is called turbid. Understand? So that means if the concentration of that electrolyte is low, then it's any solute is low, then it acts as an electrolyte. If that plus ions is there, minus ions is there. If the concentration of those ions increases, then they associated with each other. For example, starting just to 1 NaCl salt is important. That NaCl salt form 1 Na plus ion, 1 Cl minus ion. Okay, in this only 1 NaCl is there. Low concentration it form Na plus and Cl minus and it is the electrolyte. If 1 tablespoon of salt is dissolved in 1 cup of water, then so much Na plus ion, so much Cl minus ion. They are associated with each other like this. Then what happens? Size of the ions increases upon association, that is aggregation. So high concentration that behaves as colloids by undergoing aggregation. Aggregation means collecting together form a size in between 1 nanometer to 1000 nanometer. That's why they form colloids. Understand? So the best example for this associated colloids is soaps and detergents. Best example is soaps and detergents. You know that soaps and detergents in water they form a foam. Andre ಏನಂತ ಕರೀತಾರೆ ಅದಕ್ಕೆ bubbles form ಮಾಡುತ್ತಲ್ವಾ, that is called as associated colloid. What is because of the surface chemistry they form colloids. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ವಾ? ಯಾವ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? What is the action of formation of micelle? This associated colloid formation is called as micelle formation. Understand? So this can happen only at a particular temperature. So above that particular temperature only this micelle will form, means associated colloids will form. For example, ನೀವು ಕ್ಲಾತ್ ನ ವಾಶ್ ಮಾಡಬೇಕಾದ್ರೆ ಸಮ್ ಅದು ಡರ್ಟ್ ಕ್ಲೀನ್ ಆಗ್ತಿಲ್ಲ ಅಂತಂದ್ರೆ, ಕೊಳೆ ಇರುತ್ತಲ್ಲ ಕ್ಲೀನ್ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಹಾಟ್ ವಾಟರ್ ಯೂಸ್ ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ, ಕರೆಕ್ಟಾ? ಹಾಟ್ ವಾಟರ್ ಅಲ್ಲಿ ವಾಶ್ ಮಾಡಿದ್ರೆ ಬಹಳ ಬೇಗ ಕ್ಲೀನ್ ಆಗುತ್ತೆ. ನಿಮ್ಗೂ ಅಷ್ಟೇ, ಸ್ನಾನ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಂದ್ರೆ ಎಂದು ತಣ್ಣೀರಲ್ಲಿ ಸ್ನಾನ ಮಾಡಿದ್ರೆ ಕ್ಲೀನ್ ಆಗಲ್ಲ, ಬಿಸಿನೀರಲ್ಲಿ ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾರೆ ತಾನೆ. That is what, because the soap they show the property associated colloid at the temperature above a particular temperature only they are going to form micelle. That temperature is called as Kraft temperature. The temperature is called as Kraft temperature. So above this Kraft temperature only they have the capacity to form micelle. Below that temperature they won't form. If you want to check, you take a cold water and warm water, mix the soap with that. Cold water forms less micelle. Andre bubbles cold water alli kadme barutte, hot water alli ಜಾಸ್ತಿ ಬರುತ್ತೆ. Because after the Kraft temperature only they have the capacity to form micelle. And also at the same thing, ನೀವು ಒಂದು ಬಕೆಟ್ ನೀರಲ್ಲಿ ಜಸ್ಟ್ ಒಂದು ಡ್ರಾಪ್ ಯಾವುದು ಜಸ್ಟ್ ಒಂದು ಸ್ಪೂನ್ ವಾಷಿಂಗ್ ಪೌಡರ್ ಹಾಕಿದ್ರೆ ನಮಗೆ ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗಲ್ಲ, ಕರೆಕ್ಟ್ ತಾನೆ? ಒಂದು ಬಕೆಟ್ ವಾಟರ್ಗೆ ಜಸ್ಟ್ ಒಂದು ಸ್ಪೂನ್ ನಾವು ವಾಷಿಂಗ್ ಪೌಡರ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ it is easily dissolved in that. They won't form any micelle in that. They won't form any what is that, bubbles. Understand? So if concentration of that washing powder is more, the solvent is less, then they form micelle. Formation of bubbles, that is called as micelle. Means that is called as CMC. So CMC, critical micelle concentration. ಅಂದ್ರೆ ಬಬಲ್ ಫಾರ್ಮ್ ಆಗಬೇಕು ಸೋಪಲ್ಲಿ ಅಂದ್ರೆ ಇಷ್ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ಇರಬೇಕು. ಆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಗಿಂತ ಜಾಸ್ತಿ ಆಡ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇದ್ರೆ ಫಾರ್ಮ್ ಆಗಲ್ಲ. ಚೆಕ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನೀವು ಹೋಗ್ಬಿಡಿ, ಒಂದು ಬಕೆಟ್ ವಾಟರ್ಲಿ ಜಸ್ಟ್ ಪಿಂಚ್ ಆಫ್ ವಾಷಿಂಗ್ ಪೌಡರ್ನ ಆ್ಯಡ್ ಮಾಡಿ ನೀವೆಷ್ಟು ಸ್ಟಿರ್ ಮಾಡಿದ್ರು ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗಲ್ಲ. ಅದೇ ನೀವು ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಕಪ್ ಅಷ್ಟು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ನಮಗೆ ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಮೀನ್ಸ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ರೀಚಸ್ ದ CMC, critical micelle concentration. A certain concentration is there where there is a formation of micelle. These micelles form only above Kraft temperature, only above critical micelle concentration. What is CMC? That is important for 1 mark. What is CMC? That is important for 1 mark. What is CMC means? It is not critical micelle concentration. You won't write that. I am not asking any abbreviation explanation. Understand? CMC means what? We have to say. It is the concentration where there is a micelle formation takes place. What is Kraft temperature? It is the temperature where the micelle concentration, the micelle formation takes place. Understand? So this is all about the types of colloids based on aggregation of molecules. One is multimolecular, macromolecular, associated. So this one is very important. The next one we will see is the mechanism of formation of micelle. Okay. Next, mechanism of micelle formation. Important. Mechanism of micelle formation. Understand? So listen. What is the mechanism here? For micelle, I told you soap and detergents are the best example. I'll take example of soap, that is sodium stearate. Example, that is sodium stearate. Formula is CH3, CH2, 16 times COO Na. This is The formula of stearate, sodium stearate. So students listen, when it is dissolved in water, they form ions. Which type of ions? Listen, CH3, CH2, 12 times, COO minus, and also Na plus. We don't bother about this Na plus ion. It won't act in the cleaning action. Understand? So here CH3, CH216, COO, Na. When it is mixed up with water, they form ions. Understand? So this ion has two parts. One is this one. Another one is this one. Ionic part, right? So this is one, this is one. That it has two parts. So listen, this is called as hydrophobic part, means water hating. So this one is hydrophilic part, water loving. This part is hydrophobic, that means water hating. This one, COO minus, is hydrophilic, means water loving. So students, this is a long chain carbon atom. Long chain carbon atom taken as R. And this one is anion. Correct? Are you getting? CH3COO, COO minus, it is a functional group anion. It is like RCOO minus. This R is CH3CH2 12 times. You know that R may be a aryl alkyl. Correct? So CH3, CH2, 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 COO. This is the functional group. So students, this type of ion will form when the soap is come in contact with water. So this soap form two types of ions. One is cation, another one is anion. This anion consists of two parts. One is hydrophobic, another one is hydrophilic. Hydrophobic means hydro means water. Phobic means hating. Water hating part and water loving part. Okay. So students, when this type of, here I will say, this is the carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And another one is 17. 16 carbon atom plus 117 carbon atom. Okay? So listen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And here, so this is what? COO minus ion. So these are all carbon atom. This is hydrophobic in nature. This is hydrophilic in nature. Understand, students? So this is like. So what happens when what is the mechanism when the involved in formation of missile ray? Okay. So students, what happens here? Listen, this is non-polar, that is polar one. This is non-polar, that one is polar. So what happens in the miscellaneous? This non-polar bond is coming or attracted towards the center like this. This is the R group. Are you getting? This is the R group. This is our COO minus group. Okay? So this is what in shape? Spherical in shape. This is what a mesolet formation. Bubble करते रहते हैं spherical. This is how the formation of mesolet takes place. Means the cations, hydrophilic ions are out of the sphere, out from the core. This is the core, center of the sphere. Understand? And the R, non-polar, hydrophobic, are towards the core. Then they form this type of structure. This is called as mycelia formation. This is the mechanism how the mycelia formation takes place. So students, by this mycelia, listen, how this will take place. So this is the water. Okay, if they are so here, if you just shape it, here the mycelia will form, and here they are like this. R groups are towards the core and these negative atoms are away from the core. They form a spherical like structure that is called as mycelia. This is the mechanism of mycelia formation. You have to write this page. When soap, example you take this one only, sodium stearate. When soap is coming in contact with water, they form two ions. One is anion, another one is cation. This anion consists of two parts. One is hydrophobic, another one is hydrophilic. This hydrophobic and hydrophilic part is taken as RCO minus. Okay, actually the structure of the anion in the soap after dissolution is like this. So these form a mycelia structure in the form of a spherical sphere in such a way that the hydrophobic core is moving towards the core of the sphere and hydrophilic are away from the core of the sphere. Understand? So how this will work? This is one. Next, by using this mycelia, I'll explain cleaning action of soap. Cleaning action of soap. Understand? Okay, what is this cleaning action? For example, take a cloth here. In this cloth, dirt is there. This is a dirty cloth. This is the dirt. Maybe I think advertisement ಅಲ್ಲೆಲ್ಲ ನೀವು ನೋಡಿರ್ಬೋದು ಸರ್ಫ್ ಎಕ್ಸೆಲ್ ಅದನ್ನೆಲ್ಲ ವಾಷಿಂಗ್ ಮೆಷಿನ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ ಮೇಲ್ಗಡೆ ಡರ್ಟ್ ನ ಈ ತರ ರಿಮೂವ್ ಮಾಡತಾರೆ ಅಂದ್ರೆ ಜಸ್ಟ್ ಈ ತರ ಅಟ್ಯಾಚ್ ಅಂದ್ರೆ ಡಿಟೇಲ್ಸ್ ಆಗೋ ತರ ತೋರಿಸ್ತಾರಲ್ಲ ಎಕ್ಸಾಕ್ಟ್ಲಿ ದ ಸೇಮ್ ವೇ ಇಟ್ ವರ್ಕ್ಸ್ ಈ ತರ ಇರುತ್ತೆ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ ಆಕ್ಚುಲಿ ಇಟ್ ಇಸ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇನ್ಸೈಡ್ ಬಟ್ ಈ ತರ ಫ್ಯಾಬ್ರಿಕ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ಡಸ್ಟ್ ಇಲ್ಲಿ ತಾನೇ ಈ ತರ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ ಫ್ಯಾಬ್ರಿಕ್ ಒಳಗಡೆ ಅಂತೂ ಹೋಗಿರೋದಿಲ್ಲ ಅದು ಕ್ಲಾತ್ಸ್ ಇರುತ್ತೆ ಈ ತರ ಸ್ಟ್ರಿಪ್ಸ್ ಇರುತ್ತೆ ಯಾವುದರಲ್ಲಿ ಕ್ಲಾತ್ ಅಲ್ಲಿ ಆ ಫ್ಯಾಬ್ರಿಕ್ ಮೇಲ್ಗಡೆ ಈ ತರ ನಮಗೆ ಡಟ್ ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತೆ ಕರೆಕ್ಟ್ that is what I take here. This is the fabric. Above the fabric that dust is. So instead of that you take grease. It is petroleum product. Grease. Or you take oil. Grease or oil. So if you wash that, it has to remove. What is the mechanism in that? So listen, when the cloth is there, here the mycelia is there. For example, this is the dust or any grease or oil particle that is stick on the fabric. So students, here it will the mycelia is in this form. Correct? Here what happens? This is oil. This is fabric. So oil means here which are hydrophilic in nature. These are groups which are hydrophobic in nature, which are getting water. So they are stuck attached with that are associated with this oil. Understand? So these are what? Hydrophilic means ಇಲ್ಲಿ ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ಸ್ ಇರುತ್ತಲ್ವಾ ಇದು ಗ್ರೀಸ್ ಡ್ರಾಪ್ಲೆಟ್ ಅಂದ್ರೆ ಆಯಿಲ್ ಡ್ರಾಪ್ಲೆಟ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ ಇದ್ರ ಮೇಲ್ಗಡೆ ವಾಟರ್ ಇರುತ್ತೆ ಸೊ ಹೈಡ್ರೋಫೋಬಿಕ್ ಇರುತ್ತಲ್ವಾ ವಾಟರ್ ಏಟಿಂಗ್ ಅವೇನ್ ಮಾಡ್ತವೆ ವಾಟರ್ ಇಂದ ದೂರ ಮೂವ್ ಆಗ್ಬೇಕಲ್ವಾ ದಟ್ಸ್ ವೈ ದೇ ಸ್ಟಿಕ್ ಟುಗೆದರ್ ವಿತ್ ದ ಆಯಿಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಂಡರ್ಸ್ಟುಡ್ ದೇ ಸ್ಟಿಕ್ ಟುಗೆದರ್ ವಿತ್ ಆಯಿಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೊ mycelia ಫಾರ್ಮೇಷನ್ ಯಾವ ತರ ಆಗೋದು ನಮಗೆ ಸ್ಪೆರಿಕಲ್ ಆಗಬೇಕು ತಾನೆ ಕರೆಕ್ಟ್ ಅಲ್ವಾ ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ these hydrophilic COO minus ion they pull this groups to form mycelia ಅರ್ಥಾಗ್ತಿದೆಯಲ್ಲ ಸೊ ಈ ಗ್ರೂಪ್ ಅನ್ನು ಈ ತರ ಮೇಲ್ಗಡೆ ಇದೆ they pull off this group from the fabric ಅವಾಗ ಏನಾಗುತ್ತೆ ಸೊ ಇದು ಸ್ವಲ್ಪ ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ ಅಂದ್ರೆ ಕ್ಲಾತ್ ಇಂದ ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ ದೇ ಫಾರ್ಮ್ ಸ್ಟ್ರಕ್ಚರ್ ಲೈಕ್ ದಿಸ್ again micellary structure. Okay, so along with this hydrophobic algae, this dust particle also removed from the fabric. Idiru jote mix up ಆಗಿರುತ್ತಲ್ಲ. So these are the more affinity towards water. So they pull up this hydrophobic group from this cloth in fabric to form a micellary spherical structure. To form a micellary, they pull off this hydrophobic part from this dust surface or from the fabric, then they form like this. So in this micellary, dust is also involved, then the fabric become clean. This is the mechanism takes place in cleaning action of soap. How it forms. In ಹೇಳ್ತಾರಲ್ವಾ ಜಾಸ್ತಿ ಏನಾದರೂ ಫೋಮ್ ಇದೆಲ್ಲ ಅಂದ್ರೆ ನೊರೆ ಅಂತಾರಲ್ವಾ ಅದು ಫಾರ್ಮ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಇದು ಹಾರ್ಡ್ ವಾಟರ್ ಇದೆ ಬಟ್ಟೆ ನೀಟಾಗಿ ಕ್ಲೀನ್ ಆಗಲ್ಲ. ಸಾಫ್ಟ್ ವಾಟರ್ ಇದ್ರೆ ಜಾಸ್ತಿ ಫೋಮ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಬಟ್ಟೆ ನೀಟಾಗಿ ಕ್ಲೀನ್ ಆಗುತ್ತೆ ಹೇಳ್ತಾರೆ ತಾನೆ. ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಆಫನ್ ಯೂಸ್ ಟು ಸೇ in hard water it won't clean easily, in soft water they form too much foam, nore ಜಾಸ್ತಿ ಬರುತ್ತೆ ಅಂದ್ರೆ ಕ್ಲೀನ್ ಆಗುತ್ತೆ. That is what nothing but formation of micellary. If micellary formation is more, that means they are easily removing the dust particle. If micellary formation is less, they are unable to form this type of compounds, means they are unable to remove the compounds. Understand? So this is all about the formation of mechanism of formation of micellary and also cleaning action of soap. Understood? Okay. So the next one is preparation of colloids. Next one is preparation of colloids. Since we have to prepare the hydrophobic colloids. Okay, so in that 3 steps is there. One is chemical method. So students, in the chemical method only 3 reactions are there to form a gold any salt. So double displacement, oxidation and reduction. Double displacement, oxidation and reduction. These methods are used in the chemical preparation of chemical methods of colloids. Okay, so in that the first one is this arsenic oxide, As2O3, reacts with H2S, undergoes double displacement. Undergoes double displacement means 2 times it displaces, forms As2 S3 plus 3H2O. This is As2. Small s intake As2S3 plus 3H2O. Next one, this SO2 reacts with this H2S, that is 2 times. Okay, so it forms 3S, that is salt, plus 2H2O. Listen students, in the last class I gave example to you. A hydrophobic salt means sulfur in water. Sulfur in water, they won't react easily. But when the sulfur dioxide is mixed up with this H2S, then they form sulfur and water. Okay? By reacting these two, if we dissolve this H2O, sulfur directly in H2O, it won't react. This is a hydrophobic salt. It is a water 18. So then at that time, this SO2 reacts with H2S, means indirectly we can form S plus H2O. This is solute, this is solvent. Correct? Dispersion phase and dispersion medium. So this is the indirect method. Next one is Third one, FeCl3 plus H2O gives rise to 3 times FeOH thrice plus HCl 3 times. This is hydrolysis. This is oxidation. Sorry, loss of electron, right? Gain of electron. This is reduction. Okay, so these are the chemical methods used to prepare the salts, that is colloids, hydrophobic. And right here, preparation of colloid, especially lyophobic. Because as I told you, lyophilic colloids are easily prepared by mixing up with solute and solvent. Understand? So this can be prepared in a different manner. So second one method is, that is second one, predicts electric arc method. Electric arc method. So students, in this method is suitable for preparation of metallic solids or metallic colloids like gold, silver, etc. So students, here there is an arrangement. A chamber is there which consists of the two electrodes, cathode and anode, and here electricity is connected. They are connected to electrical current in the form of arc. And say here. And the electrodes, they are connected to the electricity, then they form arc, that is electric arc. Students, this is kept under ice cold chamber. This is kept in a cold condition. Understand? Means a chamber is there which is kept in a ice cold bath, cool temperature. Then two electrodes are there. Electrolyte is there, that is solvent. So then what happens? For example, it consists of a gold you are seeing. So these are gold electrodes. This is solvent plus alkali, NaOH. Water plus alkali acid. Water plus NaOH or KOH. So students, here this is the arrangement. So here electrolyte is taken, that is solvent plus NaOH, and here the electrodes are gold electrolytes or silver electrolytes, and here electric arc is formed. When the current is passed through it, then what happens? There is an increase in temperature. Electric current is formed here, then increases the temperature of this. When it reaches the trapped temperature, understand? Then they start to form colloid. Are you getting? So then what happens? This gold easily displaces from these electrodes. Then they enter into this solid. This is the way to form gold solid. Understand? This is the arrangement. So after first we need any base, NaOH or KOH now water ತಗೊಂಡಿರ್ತೀವಿ ಅದನ್ನ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಎಲೆಕ್ಟ್ರೋಡ್ ಗೋಲ್ಡ್ ತಗೊಂಡಿರ್ತೀವಿ. ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ನಾವು ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇಂದ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆದಾಗ ಅದು ಟ್ರ್ಯಾಪ್ ಟೆಂಪರೇಚರ್ ನ ರೀಚ್ ಆಗುತ್ತೆ. When they reach the temperature, then they start forming colloid. ಯಾವ ತರ colloid ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ನಮಗೆ ಗೋಲ್ಡ್ colloid ಬೇಕಾಗುತ್ತೆ. Then this gold is displaced from this electrodes, and the mix up with this solvent they form. This is the dispersed phase, this is the dispersed medium. Then they form a colloidal solution. This is another one method. And the next one is that is factorization. Very important. This one is factorization. Okay. What is this factorization? Means the process or method of conversion of freshly prepared precipitate to colloidal solution or colloid. Okay, precipitate to colloid. This is called as peptidization. Okay, the method of conversion of a freshly prepared precipitate to colloid by adding suitable electrolyte. By adding suitable electrolyte. So students, the example for this is if the freshly prepared precipitate AgI is treated with AgNO3, then they form Ag salt, silver salt or silver colloid. Next, in the freshly prepared FeOH thrice is dissolved in FeCl3, that is electrolyte, form ferrous hydroxide salt. Means the colloid, this is completely dissolved in water. This is a true solution. Understand? So it is precipitated as AgI. So the particle size is more. Precipitate means we can easily see them. White precipitate, violet precipitate, brown precipitate, you know that in salt analysis. So if it is mixed up with AgNO3, then it is easily dissolved. Understand? When it is dissolved, not completely, partially dissolved, then that form a colloidal solution. Means the AgI has the size of the particle more than 1000 nanometer. This one is less than 1 nanometer. So when they mix up with each other, then the size become in between 1 nanometer and 1000 nanometer. That's why they form colloids. This is another one, that is factorization. The method of conversion of freshly prepared precipitate. These two are the precipitate. They are mixing with what? Suitable electrolyte, AgNO3 and FeCl3. Then they form colloids. One is Ag colloid, another one is ferric hydroxide colloid. Okay, so this is all about the preparation of lyophobic colloids or lyophobic salts. Okay, so in the next class we will discuss about separation methods, purification of colloids. Okay, thank you.